Let's consider the question on the board. We are asked to find the derivative of the following function using the chain rule. You see, don't forget in our previous class I told you the basic representation of the chain rule of differential calculus is this. The y dx is equals to derivative of y with respect to u multiplied by derivative of u with respect to x. Now, u is the inner function. Okay, so let's start with the first question. Solution. Let's start with the first question. We are asked to find the derivative of square root of 2x raised to the power of 3 plus 1. Let y equals to square root of 2x raised to the power of 3 plus 1. Okay? Now, you can see that this kind of question has another function in itself. You understand? Don't forget, I told you, chain rule is used to differentiate a function that has another function in itself. Looking at this, you can see that y equals to square root of 2x raised to the power of 3 plus 1. 2x raised to the power of 3 plus 1 itself is a function. Now, y equals to square root of 2x raised to the power of 3 plus 1 is another function. So, the first step is that we can rewrite this as this. Y equals to 2x raised to the power of 3 plus 1 raised to the power of 1 over 2. You understand? Okay? Because square root simply means half. Okay? Now, the next step is that you have to represent the inner function as u or any letter. You understand? Now, in this case, I'm going to have u equals to 2x raised to the power of 3 plus 1. The function inside the bracket is what we call the inner function. Okay? Now, so you can now say, because u equals to 2x raised to the power of 3 plus 1, that means that y will be equals to u raised to the power of 1 over 2. Do you understand? Because we've represented u as 2x raised to the power of 3 plus 1. So that means that y will be equals to u, which is represented as 2x raised to the power of 3 plus 1 to the power of half. Okay? Now, the next step is to differentiate both the inner function and the outer function. I'm going to have the u over the x is equals to 6x, and the y all over the u is equals to 1 over 2 u raised to the power of negative 1 over 2. Do you understand how I got this? Listen. According to the polynomial rule or the power rule, it is very important that you return back to our previous class and learn it, okay? Learn it. Now, according to the polynomial rule, u raised to the power of 1 over 2, derivative will be what? U raised to the power the derivative will be 1 over 2 multiplied by u raised to the power of 1 over 2 minus 1. Okay? That means I'm going to have 1 over 2 multiplied by u raised to the power of 1 over 2 minus 1 is what? Minus 1 over 2. Minus 1 over 2. That's why I got minus 1 over 2. Okay? So, let us proceed. Now, from this point, we can use this formula now. We have dy all over dx will be equals to dy all over du multiplied by du all over dx. Okay? Dy over du is what? Dy over du is u raised to the power of negative 1 over 2 all over 2. Okay? Listen, I've not done anything. See, 1 over 2 multiplied by u raised to the power of 1 negative 1 over 2 is all the same thing as u raised to the power of negative 1 over 2 all over 2. This 2 that you see here is this. And this u raised to the power of 1 over 2, if you multiply 1, it's still going to remain like this, okay? If you multiply 1 by this, we are going to have this. So I've not done anything. Do you understand? Now, after this step, du dx is 6x. So I'm going to have multiplied by 6x, okay? Dy dx. Okay? Now let us proceed. Dy all over dx is equals to u raised to the power of negative 1 over 2. What is the meaning? That means u is what? 2x raised to the power of 3 plus 1. So I'm going to have 2x raised to the power of 3 plus 1 raised to the power of negative 1 over 2 all over 2 multiplied by 6x. Okay? Now, please kindly pay attention. According to the laws of indices, if you have x raised to the power of negative 1, that will be what? 1 over x. If you have x raised to the power of negative 2, that is what? 1 over x squared. Is that not it? Now, if you now have x raised to the power of 1 over 2, negative 1 over 2, That will be what 1 over x raised to the power of 1 over 2, you understand? Which can be written as 1 over square root of x, because half, the power, which is half, is what? Is square root, you understand? So we are still going to apply the same with what we have in our in this derivative. So please kindly pay attention, okay? Here I'm going to have dy all over dx is equals to 1 over 2 multiplied by 1 over 2x raised to the power of 3 plus 1 raised to the power of 1 over 2 multiplied by 6x. Do you know what I did? 1 over 2, this 1 over 2 that you see here is this. You understand? You see, please kindly pay attention. The function, this function that you see here can be written as this. It's just like saying that 2x all over 3, it can be written as what? 1 over 3 multiplied by 2x. Do you understand? So that's what I did. I just extract this fraction over 2. This is it. Okay? And I knew that with respect to the law of indices that I showed you earlier, 2x raised to the power of 3 plus 1 raised to the power of negative half can be written as this. Okay? Because of the negative sign. Now, this 6x is this. Having done this, you can simplify. dy all over dx is equals to 1. Okay, 1 times 1 times 6x, that's what? 6x. 6x all over 2 multiplied by square root of 2x raised to the power of 3 plus 1. Okay? So you can see, okay, yes, 2 times this, that is what? 2 multiplied by square root of 6, like square root of 2x raised to the power of 3 plus 1. Now, I want to pay attention. This can be reduced as this. Dy all over dx is equals to 3x all over square root of 2x raised to the power of 3 plus 1. It's just like saying I divide these 2 by this 6 by this 2. That's what? 3x. So I got this. Okay? 6x divided by 2 is 3x. 2 divided by 2 is what? 1. 1 times square root of 2x raised to the power of 3 plus 1. That is what? Square root of 2x raised to the power of 3 plus 1. Okay? So that is the solution to that question. If you have any question, let me know in the comment section. Let us proceed to another question. That is question number 2. Okay? To solve the second question as well, let y equals to the cube root of 4x raised to the power of 3 plus 2x. Okay? So, now, the next step is that you have to set the inner function to u. You understand? You can use any letter, but because the letter contains in my formula is u. You understand? So, I'm going to make use of u. Okay? So, I'm going to have u will be equals to 4x raised to the power of 3 plus 2x. Okay? That means that y will be equals to the cube root of u. You understand? Okay? And we can rewrite this as y equals to u raised to the power of 1 over 3. Okay? So, and u will be equals to 4x raised to the power of 3 plus 2x. Just like the approach that we used while solving the first question. Okay? Now, the next step is that just take the derivative of both u and y. So, the u all over the x is equals to 12x squared plus 2. And the y all over du is equals to 1 over 3 multiplied by u raised to the power of 1 over 3 minus 1. 1 over 3 minus 1 is what? Negative 2 over 3. So let us represent it as negative 2 all over 3. Okay? Now, having gotten to this point, the next step is that just use the formula directly. According to the chain rule formula, dy dx is equals to dy du is equals to dy du. Dy du is what? 1 over 3 multiplied by u raised to the power of negative 2 over 3 multiplied by du dx. Du dx is 12x squared plus 2. Okay? Here I'm going to have dy all over dx is equals to 1 over 3. What is u? U is what? 4x raised to the power of 3 plus 2x. That will be what? Negative 2 all over 3 times 12x raised to the power of 2 plus 2. I'm very sure you understood what I did here. You see, I've not done anything. All I do is that I just replace this u as what we have here, 4x raised to the power of 3 plus 2. Do you understand? Now, the y all over the x will be equals to 1 over 3 multiplied by 1 over 4x raised to the power of 3 plus 2x raised to the power of 2 over 3, okay, multiplied by 12x raised to the power of 3 plus 2, 12x raised to the power of 3 plus 2, okay, okay, plus 2x, not plus 2, please kindly pay attention to the x, it is plus 2x, okay, not plus 2, see, sorry, it is the u dx, I thought it is this, 12x squared plus 2, it is plus 2, sorry, it should be plus 2, okay, I actually, I made a mistake, I thought it is this that I'm substituting, I forgot that I've already differentiated, so the u dx is what? 12x squared plus 2, 12x squared plus 2, so it is what? 12x squared, it's not x squared but 12x squared plus 2, you understand? Okay, now, the next step now is that you just have to take the cross product, take the product. So here I'm going to have the y all over the x is equals to 1 over 3 multiplied by 1 over the square root of, okay, the cube root, okay, the cube root of 4x raised to the power of 3 plus 2x raised to the power of 2 multiplied by 12x squared plus 2, okay. See, we are done with the differentiation. I'm just simplifying it, okay. So here I'm going to have the y all over the x is equals to 12x raised to the power of 2 plus 2 all over 3 cube root of 4x raised to the power of 3 plus 2x raised to the power of 2, okay. So that is the derivative of the function, okay. This is the derivative of y equals to cube root of 4x raised to the power of 3 plus 2x is 12x squared plus 2 all over 3 multiplied by 4x and the cube root of 4x raised to the power of 3 plus 2x squared. Do you understand? Okay, so now we have the third question. We are told to differentiate sine 2x plus 4. You can see that all the functions that we are differentiating have both inner and the outer function. The inner function is the function inside the bracket, and the outer function is the function that we are given itself. Okay. Now let's proceed to question number 3. Okay. The first step is that just let y equals to sine 2x plus 4. Now, the inner function in this function is what? Is 2x plus 4, because that is the function inside the bracket. So let the inner function equals to a letter. In this case, I'm going to use u. U equals to what? 2x plus 4. In that case, y will be equals to sine u. Okay? Now, according to the chain rule formula, we need the derivative of y and u. So I'm going to differentiate u. The u all over the x is equals to 2. And the y all over the u is equals to cos u, okay? If you differentiate sine u, you're going to get cos u, you understand? Okay? Having done this, the next step is that just take the product of du dx and dy du. You're going to get the value of dy dx, okay? So dy all over the x is equals to dy all over du multiplied by du all over the x. Okay, dy du is cos u, so I'm going to have cos u multiplied by 2. That is what? 2 cos u. Now, don't forget that u is equals to what? 2x plus 4. 2 cos u. 2 cos u. That means that dy all over dx will be equals to 2 cos 2x plus 4. Okay, so that is the solution to that question. Now, I want to do something. I want to attempt question number 4. Okay, the solution to that question number 4 will be, I don't want to give you the solution, just attempt the question number 4. Okay, drop your answer in the comment section. Let's go to question number 5. Question 5, all you have to do is that just let y equals to sine 2x minus cos 3x. Now, If you want to differentiate this using the chain rule, you have to differentiate them individually. You understand? Now, if you want to differentiate sine 2x, you are going to have 2 cos 2x. And if you want to differentiate negative cos 3x, you are going to have negative into bracket negative sine, okay, negative 3 sine 3x. This is what we're going to have. How do I get it? Just pay attention, okay? We have sine 2x. Let's set sine 2x equals to a letter. Let a equals to sine 2x. Let a equals to sine 2x. Now, using the function of a function, we have to set u equals to what? 2x. That means that a will be equals to what? A will be equals to sine u, right? So the u all over the x will be equals to 2, and the a all over the u equals to what? Sine u will give what? Cos u, okay? So, and what we are looking for is the a dx, you understand? The a all over the x will be equals to the a all over the u multiplied by the u all over the x, okay? Now, the a over the u is what? Cos u, okay? The a over the u is cos u multiplied by the u dx is 2. So that is what? 2 cos u. Now, don't forget that u is what? U is 2x. So I'm going to have 2 cos 2x. That is how I arrive at 2 cos 2x. You understand? Okay? Now, let us proceed to differentiate the second function. I just show you how I got 2 cos 2x now. Now, let us get the derivative of negative cos 3x. Now, set a equals to negative cos 3x. Are you there? Now, let us set u equals to 3x. That means that a will be equals to what? Negative cos u. You understand? Now, let us take the derivative of both u and a. What we are looking for here is the a dx. You understand? So, let us take the derivative of both u and a. The derivative of u is what? The u dx is what? That is 3. And the a over the u is equals to what? Negative into bracket negative sine u. Because this negative that you see here is it. Are you paying attention? Now, if you differentiate cos u, you are going to get minus sine u. You understand? So, that is how I got this. So, the a over the x for this will be what? Minus times minus is plus. So, I'm going to have sine u multiplied by 3. So, that is what? 3 sine u. That is 3 multiplied by 3 sine u is what? 3x. So I'm going to have 3 sine 3x. So that is how I got negative. If you take the product, you're going to have 3 sine 3x, because minus times minus will eventually becomes plus. So that's how I got 3 sine 3x. Do you understand? I'm going to give you a formula that can help you to differentiate a function of a function within a short period of time, okay? All you have to do is just to pay attention, especially when you are dealing with trig. You understand? Function that involve trig, function that involve sine, cos, tan, sec, cosec, and others like that. I'm going to give you a formula that will help you to differentiate it so fast, okay? So now, the derivative of y, I'm very sure you understood what I did here. I just differentiate each of them individually using the chain rule formula, okay? So when I differentiate 2x, I got 2 cos 2x. The derivative of y is equals to 2 cos 2x plus 3 sine 3x. Just like I've already showed you the formula, okay? So that is it. Now, let me give you the formula that you're going to use. If you are dealing with function that involves trigonometry, like that involves all the sines, cos, you can use this formula. Let's say you have to differentiate y equals to sine u. You know that for a basic calculus, the derivative of sine x will give us cos x. So sine u will give us what? Cos u. But since we have another function in sine u, you're going to have the derivative of y will be equals to cos u multiplied by derivative of u. You understand? If you have to differentiate cos u, the derivative of y will be what? Sine u, negative sine u multiplied by derivative of u. Now, let us use this formula using, and let us use the formula to differentiate this. We have y equals to sine what? Sine 2x, sine 2x plus 4. In this case, u is what? 2x plus 4. The derivative of y will be what? Sine will give cos. So I'm going to have cos 2x plus 4 multiplied by derivative of 2x plus 4. That is what? 2. So I'm going to have 2 cos 2x plus 4, which is the same answer that we got when we find the derivative of this using the chain rule. You can see now. So with using this formula, you can easily differentiate a function that's also another function in itself, especially those that involve sine, cos, tan, sec, cosec. Don't worry, by the time we delve into this concept, you are going to understand better, okay? So now, I want to use the same approach to differentiate this question number 4. What will be your answer? We have y equals to cos x squared minus 4. And you know that derivative of cos will give us what? Minus sine, negative. So I'm going to have derivative of y equals to negative sine x squared minus 4 multiplied by derivative of x squared minus 4 is what? 2x. So multiply by 2x. That is what? Negative 2x sine x squared minus 4, which is the final answer. You can see that this rule, this one is very simple. So master this, okay? Master this. I'm still going to give you more in the next class. I'm going to give you. So I want to master this formula. I'm still going to give you more. You understand? But in this class, let us limit it to these two, okay? In our next class, we're going to delve more into. So kindly pay attention to this formula because you are going to be using it in chain rule. Are you paying attention?